Okay, so play for what, 10, 15 minutes and it cuts out? That's what it's doing?
Yeah, at full volume.
Okay.
Play for 10, 15 minutes, it'll just totally cut out. I can play with the master down, or I can play clean, and I can play all night with it.
Yeah.
But if I'm playing dirty with the master volume, it will cut out.
Okay. Did you ever take the back off of it and observe what the tubes were doing at the time? That okay, could just be running away, bias. I've had Marshalls that would just, the bias would start running away at some point, and it's those were really difficult to diagnose, and they ended up being board issues. Hopefully that's not this.
Yeah.
But we'll take a look at it, man, and see. But like I said, I just wanted to get this clip to make sure I remember what's up with it.
And I mentioned this before, that I had it retubed maybe a couple years ago.
It didn't do this before that?
It didn't do that before,
Okay.
but I do know that once it was biased, when I had it retubed,
Yeah.
it acted different. I mean, I had to literally have the master on 12 o'clock or 1 o'clock to keep up with the drummer.
Oh, okay.
Instead of normally, the master would be like at 9 o'clock.
Gotcha. Well, maybe that's...
So I think the bias, it wasn't biased right.
Okay.
I don't think.
We'll check that. Okay, so here we've got this Marshall combo up on the bench. This is the Haze 40. And like the guy said, it's got some problems. So let's pull the chassis and get to it. Okay, so we've got this open. We can see what's going on in here. Obviously, we've got PCB here with direct mounted sockets. The thing about direct mounted sockets usually is because of the heat involved in tube amps, they can sometimes, and also because you're moving tubes around, putting them in and out. I don't know how they have those attached on the other side to the chassis. It's possible they've got them screwed onto the chassis as well. I'm assuming they do have those reinforced onto the chassis, but still sometimes you can have problems like bad solder joints on the tube sockets, and problems like that can manifest themselves after the amp has been on for a little while and has heated up, and obviously things are expanding and contracting, expanding when it's heated up, and that can cause issues. I do see what looks like possibly one bad solder joint already on a tube socket. They must have those power tubes on standoffs. I don't know what's going on with that, because I'm feeling underneath. My power tubes are here. My power tubes are here and here. V4 and V5. Look at this. Okay, so there's V1, V2, and I can feel underneath, and yes, indeed, those are 12AX7s or something like that. They're miniature 9-pin tubes. Number 4, however, right here, and also number 5, V4, V5. These two right here, look at the size of them. We've got 1, 2, 3, 4, 5, 6, 7, 8. That's 8 pins right there, but that's too small to be an 8-pin octal tube. So our sockets are probably mounted to the chassis, and then there's wires running up to here probably, or these leads are running up to here from those sockets. You see this one, V5. Look at that right there. You see what I see? See what I see right there? That looks to me like that could be a bad solder joint right there. That looks really highly questionable. Right here. That to me looks highly questionable. Wouldn't hurt to reflow all of these. This one especially has not a lot of solder. The rest of these look probably okay, but this one and this one especially. And then there's another one over here that doesn't look great at all. That one down in there to me doesn't look great either. It looks like it is connected, but it doesn't look great. It looks like it could stand to be reflowed for sure. So I think the first step is going to be to reflow some solder, take some measurements. Also, we've got these power resistors here up on these big standoffs. So you can see these right here. Probably would not hurt to reflow all the solder in there as well. Don't know if you could see it, but some of that looks really sloppy too. And I think I can flow all that without pulling this board. What else? Do we have a can for capacitor can here, or are we relying on these guys? Yeah, that's a 47 microfarad at 500 volts. I would say that one is 247 at 500. They look good. I don't see any issue with them. They don't look like they're exploded or bulged or anything like that. I don't see where any of these smaller ones are either. That's usually, you know, first things I would check is to make sure that none of the capacitors are obviously bulged out or exploded. And an amp that's relatively new like this, I mean, you know, new as in made in the last, you know, 10, 15 years, 20 years, I wouldn't necessarily expect capacitors, or unless there was a manufacturing fault, to be at fault. We got a little daughter board on the back down there also. You can see it's for the outputs and everything. Got some stuff running to and from that back there. We do have one larger resistor here. That's probably a dummy load resistor. If somebody unplugs the speaker and then tries to run the amp without a speaker plugged in, it probably goes through that resistor right there and uses that as a dummy load. That's my guess. That's what that's probably for. Does this have a headphone out as well? Because if it does, then that might also be part of the headphone out circuit. It may defeat the output speaker and put all the load, dump the load into a resistor. No, it's nothing like that. It looks like it's got, we got a high tension fuse, connect speakers before use, but that probably still is what that bigger resistor is. Emulated line out. Okay, so that's a speaker emulated line out, so you can go directly to a board or whatever for recording. 16 ohm and an 8 ohm speaker outputs here. Okay, effects loop on off, return send foot switch. He's got it hooked into the 16 ohm, and this speaker, it's a Patriot Swamp Thing by Eminence. I don't know if this would have come with a Kentucky made Eminence in here. See, that makes me so proud every time I see that. Made in the USA in Eminence, Kentucky. Right down the road from me. One of these days, man, I've been meaning to go and check out the Eminence factory. If you want to see me go to the Eminence factory, tell me down in the comments. And one of these days, you know, if enough people want to see that, we'll take a trip over there together. Okay, that's a 16 ohm. So that's good. That's fine. You'll also see on this model, we've got some effects here, some built-in effects that are digital. By the look of it, we've got some digital effects. Got a little momentary switch here on the face for echo, vibe, and chorus. The amplifier and everything is all tube driven, and with the exception of this stuff right here, it's, you know, it probably is fairly straightforward. Let's see, how's the switching done on this? This is probably DC relays. Got a relay here, got a 12 volt, so they've got a 12 volt rail. That's a 12 volt relay. Looks like a couple of relays here, probably two. I think that's what those are. I don't recognize them offhand, but I think that's a relay. Another one back here. So those are probably for the switching. Got a couple of pots here. I would assume those are in the bias circuit. For it looks like they're doing this independently for VR1, VR2. I'll tell you what. Before we go any further, let's see if we can find the schematic for this. Yeah, I'm interested to see if we can find that schematic. I also want to check this fuse, make sure he didn't blow a fuse before he brought it in. He said it was cutting out, not that he was blowing fuses, but that it was cutting out. But I don't know, just to be thorough here, I want to make sure we've got a good fuse, and it looks like we do. All right, that's a 500 milliamps, so that'll be your high tension fuse right there. And then there will be another fuse in here for the mains. Yeah, that looks like a good fuse as well. Let's see if we can find a schematic for this first, because I'm just curious to see what kind of switching this amp uses and all that kind of stuff. It's just, it's usually pretty neat to see that sort of thing anyway. It looks like some little mouse or rat or something had a nest in here, or at least had a meal at some point, so we might check these wires and see if anything's exposed has been chewed on, actually. Okay, I was able to find a schematic, and the model number on this, the actual model number, it's on the back of the amp also, is an MHZ40C. But anyway, a couple other things that I do notice about this right off the bat. First of all, I mean, you can see what kind of a pain in the butt this is to get to the tubes. I mean, you got to reach up in, way back in here to see the tubes, let alone pull them out. That's strike one for me for ease of maintenance and things like that. You want to really see the tubes. That's why it's so nice to have tubes that come out the bottom. I guess the only good thing about that is that they're away from the speaker, but still, I don't like it. But they're not really away from the speaker, honestly, because the speaker still is throwing pressure waves right at the... Yeah, they're still pretty close to the speaker, so it really doesn't matter. It would be just about the same. One thing I do like is that they've got the input jack separated. Over here, you can see there's a breakout. The jack is on its own little separate board that's broken off of the main board, so there's perforated tabs. So those can be broken off during assembly, and this thing is assembled with a wire that goes from here to here. So if the jack starts to rotate or something on you, it's not gonna, you know, break everything on the board. So that's nice that they do something like that. It prevents little headaches like, you know, a bad jack. Still, I just don't like the layout of this. I don't like the way these are put together. Stuff like this. I mean, yeah, I mean, it's all through hole stuff, most of it, with the exception of this board, which is SMD, and at least it's stood up off of the main board. It's on a separate board. It can be replaced separately if need be, and it's not going to be subject to the direct heat of the tubes. I guess it's the other good thing of the tubes being sideways like that is the heat's going up and it escapes out the top of the cabinet instead of going up into the chassis. So that maybe is one good thing about that. But I don't know, man. I like to be able to see the tubes. I like to be able to access the tubes at a glance. I like to see what are the tubes doing. Are they overheating? Are they, you know what I mean? With it plugged in, can't even see the tubes. So this guy wouldn't be able to tell me whether it was red plating at the time that the amp goes dead. You know, I mean, just little things like that. Like I said, I was able to find the schematic. I'm going to go ahead and pull the chassis out of here. And since we do have evidence of critters having been in here, I want to make sure that they didn't chew on something that's maybe exposed out there that might be kind of shorting out or something. I want to make sure that that's okay. Then we'll come back and we'll check the bias on this. Look at this chassis. If they had just made this front mounting, this would have been fine. You'd have been able to see the tubes and access the tubes just like normal, you know, on an old school Marshall combo. If the, you know, controls were front facing. This way, it does make the baffle, you're able to make the baffle bigger, but still, this is a pain in the butt to do it like this because look at this. I can't, there's nothing back here. I can't just plug in to the output to my dummy load. The freaking output is on this bent piece right here. They had to make it like this. I can't plug it into the power either like this. You know what I mean? It's so stupid. Got this thing all hooked up, got it hooked up to the dummy load, got it hooked up to a couple of probes on the output tubes. Yeah, time to see what's going on here. Let's fire up the signal generator and let's get this thing hooked up as well. Let's get our meters on here. All right, so here's what we got going. We've got our probe right there. That is going to the oscilloscope directly from the output. This is the dummy load here. We've got it set to 16 ohms. Got the output coming out of 16 ohms. So we'll be monitoring what's on the output at the oscilloscope. We have some meters here. We've got 3 of them, in fact. Well, 4 of them if you count this one here. So this will be all the input stuff that's going into the front end, or into the power for the amp from our Variac. This will be measuring plate voltage coming off of this meter here. This will be measuring the plate current through one of the tubes. This will be measuring plate current through the other tube. And again, this will be plate voltage, which should be pretty much roughly shared between them anyway. I mean, we can double check that, but they should be about the same. If we wanted to, we could even put another measurement on this other side, but I don't think we really need to do that. Let's get a signal pumping. So we got signal coming from channel 1 of this signal generator up here. Signal's coming out of there and going to the input right there. He said that the problem was it cuts out after a while, so we'll probably have to leave this thing on for a little while, let it get warmed up before we can recreate the problem. Okay, we got the power set to on, we got the standby. Let's dial it up on the Variac and see what kind of readings we start to get over here. You can see we have plate voltage. I'm gonna get us up about halfway on the Variac. Right now we're at 46 volts. And once the tubes start conducting, which they should do here in just a second or so, we'll start getting readings over here. Sometimes it takes a second. Yeah, I'm starting to hear clicks on these relays. Look at that one over here as you're jumping around. Look at that. jumping all over the place. Okay, this one's behaving in a way I would assume would be correct, but this one's jumping all over the place. I don't know what's up with that. That's the plate current, just jumping around like that. I want to rule out a metering error. I don't think it's a meter, but I want to rule out some kind of meter error, so I'm going to swap those meters around and see if it follows the meter. Okay, I've swapped those two meters around. Let's fire this thing up again and see if it follows the meter or if it stays put. Okay, that's the same input voltage we were at a minute ago, 88 volts. It's following the meter. It follows the meter. So we got some kind of issue with that meter right there. So maybe dying battery, something like that perhaps. I mean, it's a cheap meter. So let's change that meter out. Okay, new meter with a fresh battery. Let's try it again. Okay, this one's still jumping around. Jump around! But that's a different meter. I'm actually really confused now. Huh. Our plate voltage is jumping around quite a lot too. Jump up and get down! That stabilized it. What happened there? All I did was change the channel. Hit the channel button. And it starts jumping around like crazy. What the hell? That's the plate current jumping around like that. What would cause plate current to jump around like that? I mean, if this was an old school amp and I saw numbers like that going crazy on the plate current, I would think, hey, this probably has bias adjusting tremolo or something on it, but this doesn't have that. So I don't know why it would be doing that. Let me dial it up just a little bit more and see if it stabilizes itself, or maybe another relay kicks in or something like that. I mean, see how this one, it's moving, but it's moving linearly. It's just kind of going up. But this one right here is just jumping all over the place. It's going from 35 down to 28. It's just jumping everywhere. If we hit this, though, look. It completely stabilizes. I'm going to see if I could change this effect and see what the current does there. Change the channel again. Good God. It's just spiking all over the place. Whoa. All right. That was interesting. I don't know. Could you see that? Could you see the current? And also, I was hearing something weird, like maybe I was hearing signal, actually. But what was happening is, I changed the effect, and this spiked all the way up to like, how high did it get? I don't know, you have to slow it down and see how high it gets. Changing the digital effect is actually changing that plate current. It would be changing the signal and therefore the plate current, because it's not at idle. We got both of these turned all the way down, both channels. And now when I change, there isn't very much change at all. So that explains that. We were switching channels. I wasn't thinking about this right, because I have a signal going in, so that explains that. And then when you change the effects, that's going to change the signal also and affect that plate current. But, okay, so these are all the way down now. The amp is at idle. Here's our readings, and you can see they're kind of far apart. Let's see what the plate voltage was. It was 300 something a minute ago. Yeah, 332. Let's go ahead and dial it on up a little bit. I want you to see all these numbers right here. I know this is kind of boring and it's kind of mathy and all that, but this is pretty essential in understanding what's going on with the amp. So this is what we've got coming into the amp from the wall. All right, this is where the power is originating from, and we've got 88 volts here. Let's go ahead and dial this on up to operating voltage. 119, 120, something like that. I think 117 is actually probably, that's reasonable. Let's stop right there for a minute. Now you can see the disparity between these two numbers here. See how this one, don't ignore the negative right there, that's meaningless. 21.9 and 35.9, those are vastly different numbers, indicating we've got either one of these tubes has changed a lot, has been weakened by, you know, maybe more wear than the other, or it could be that the bias is simply that far off. So let's see what we're dissipating on both of these right now at idle. Everything okay?
Yeah, can you follow me to the basement? I almost stepped on a cave cricket and it jumped away, but it's somewhere on the step and I can't see it. Can you get?
Do you want me to follow you?
Do not post that.
I'm not gonna post that. I'm not gonna. here's what we're looking at. The effects is what part of the problem was. If we turn the waveform up here and we turn on the effects, you can see what the effects kind of do to the wave. Can do a lot of different stuff to it. You can see it goes way down and then comes way up because the adjustment's way low. If you want to make that more rapid, you can. That's kind of, I think that's the vibe effect, if I'm not mistaken, that you're looking at. You can also see what it's doing to that plate current at the output. There's, you know, it's fluctuating wildly, and it's doing it more on one side than the other side. You can slow it way down too. You see the adjustment is real slow, and the depth is way up. So you can see the difference in volume that's producing too with the final output signal. And you can see the spike in the output. But like I said, let's turn this off. To me, that looks pretty good. I want to dial these in a little bit better, and then we'll probably come in here and do a little cleaning on these pots, and I'll flow some of the solder on these tube sockets, and I guess wish for the best on this. Okay, so I've decided to put these right at 50%. So about 2.9 times 427 plate volts, and I've set both sides to that. So we're right about at 50% plate dissipation for both tubes. So I'm going to leave it right there at that. It looks pretty good on the scope as well. We'll check it out. Turn it up here. Again, that's just my meter telling me I don't have enough battery power to keep reading at this rate. It's kind of a warning, which is nice, but it's also annoying. You can see that looks like an excellent wave, and if I go ahead and continue to turn it up a little bit, it'll square off from there, and then right after the square off is when we start getting our crossover distortion here in the middle. So to me, that looks fantastic. That's the maximum amount of clean headroom on the amp. Looks great, and I don't see anything running away or anything like that. I mean, like I said, I could still this side's actually a little bit, it's drawing a little bit more at the moment than this side, but they do kind of cool down and back down. If you leave them for a second, it should level back off. That's interesting that it stayed high. I don't know. Sometimes whenever you draw current through a potentiometer like this, it will actually change the value because it, you know, I don't know why. The electrons kind of take a slightly different path. Maybe there's some tarnishment in there, and I need to kind of scrape it off, but we do need to get this back down, though. Just going to wiggle this pot a little bit. It might need to be cleaned, but it's sealed, so I don't think I can clean it. We'll heat it up and turn it down a couple times like that. Let the tubes warm up. And then we'll cool it down and just see where it kind of goes back down to. Okay, now we've got those dialed back in together. Let's try that again. We'll dial it on up. Just let them cook for a second together. And you can see right here at the maximum, they're drawing about the same at this level. They are backing off at different rates though, and they kind of settle down at different rates. So I think one of the tubes might be more tired than the other one. But at idle, they're leveling back off pretty well, pretty nicely together. And we're not at any kind of excess right there. If we check it again, so 428 volts times 0.0297, that's about 50% of plate dissipation for an EL34. So I'm going to call this good right now as far as the bias goes. I will continue to maybe check this a couple more times just to make sure that everything is going to be steady and stable. Maybe let this kind of run at this kind of level, at sort of the overdrive level, for a couple minutes. Okay, this is the overdrive channel. You can see that wave is much more compressed on the top and the bottom, rounded off and just compressed down, squished. Yeah, I'd say at idle that's looking pretty good. I think this is probably okay. I want to go ahead though, like I said, I want to flow all the solder on all the sockets. Maybe flow the solder on these larger resistors as well, possibly while I'm in here. Those are the main ones where you have to really worry about that sort of thing. Yeah, let's just kill it for now. I think we got a game plan.
I mean, if you were the president, what would you do?
If I'm the president, I'm gonna do mass deportations.
Alright guys, it's the next day now, and I have been steadily testing this thing out. Yesterday I left it on for more than a couple hours. I did at one point hear some kind of little, like a pop, like a poof. It just sounded like maybe for 1 second a tube kind of rattled loose and then reseated itself perhaps, or something like that. It's what it sounded like. That's the only thing I could get it to do, like in terms of any kind of failure. I actually left it not on standby, but I left it on. And then I would come back to it every now and then, every 15, 20 minutes or something, and just see if it was still playing, and it was. So, I mean, I think this thing's ready to go. I think it just had a bias issue. The bias was getting too hot, and it was thermally sort of shutting itself down. Either that, or it was a problem perhaps on the one of those pins for the output tubes, like we theorized at first, possibly. But this thing sounds pretty good. I mean, it's got... good Marshall tone. I mean, it's got a pretty good normal channel as well. That's obviously that's the overdrive channel with the boost on. The normal channel, you can actually get it to drive as well. It's got a pretty good clean tone, but it's also got a good overdrive when you push it. It has a boost button as well. You take the boost button off, of course, you're going to get a cleaner tone. I don't know if you can hear that right there. It sounds like a little tiny little bit of a pop. It's like a tick tick kind of a thing for a second, but then it goes away. Here's with the boost on the first channel. So you get the idea, and then you got the effects on top of that. We'll try out, let's see, this is green, so we're trying out the echo. This is the echo effect. pop there? I don't know what that is. Again, that's the echo. Here's the vibe. No, wait, that's the echo. You hear that little tick right there? It's also got chorus as well. The chorus is pretty good. There it goes. What was that? Okay, now we got to figure out what happened there. Finally made it happen. I've been doing this for 2 days. Can you even see? I don't know if you can see or not. I don't see any red plating at all. It has cut out. So yeah, like I said, it took me 2 days to get to this point. I got to quickly pop these screws back off the back of this before it comes back to life. So it happened that time when we're in the chorus setting, and we were on the clean channel, normal channel, no boost, and there's the rest of our controls. You can't even reach the tubes to wiggle them or do anything without taking this entire back panel off. It's kind of a pain in the butt. Let me turn the effects off. Does it come back turning the effects off? No. Let's grab a chopstick and chopstick around on this for a second with it open. Change channels. I can hear it change channels, so that part's actually working. But then there's nothing at the output. I can hear the effects changing. I guess the thing really to do while it's in this state, because like I said, it's taken me a couple days of messing with this to get it to this point, and I don't want to squander this opportunity. Probably the best thing to do right now, while we have it like this, would be to signal trace. I can still hear hum and noise coming out of the output. So somewhere along the line, the signal's being interrupted. I'm going to try to pull V1 and reinsert it. There, it comes back. So is it a problem with the V1 socket? Oh, that right there. What was that? That sounds like that might be an internal short starting to occur on that 12AX7, because I was hearing something when I tapped on that. Right there. Right there. Right there, you hear it popping. That capacitor right there doesn't like being tapped. It looks like. I don't know if that has anything to do with it, but see, that's the thing too. I would assume that thumping that 12X7 would cause those electrodes to short out. I don't think it may not be the 12X7 after all. I think one of these capacitors right here, one of these four, this one, this one, this one, or this one, are failing internally. I think that's what's going on here. That would cause the issue that we're seeing, because when you reinsert the 12X7, there's a current spike through the that coupling cap, and it just suddenly can sometimes awaken the cap, you know, temporarily until it heats up again, and then the whole cycle starts again where it shorts or opens up, and that would make sense. But it's also unfortunate because that would mean we would have to pull this entire board to fix that. It doesn't seem to be doing it now. It makes me wonder if simply uninserting and reinserting that tube fixed it. I mean, sometimes that does happen just because you get a bad connection on a tube socket. That's possible. It does happen. And then, of course, when you're hitting around the tube socket, you know, you're causing that faulty connection, that little corroded connection to disconnect and reconnect and stuff like that. So that's why you would be getting little pops. And when you're playing, especially in a combo like this, you know, all of the vibrations are causing that little piece of corrosion or whatever it is that's causing the separation of the pin and the terminal to kind of connect and disconnect on and off. So anyway, I'll play with this a little longer and see if I can't get that to occur again. But for right now, at least, it looks like this is, unless, what was that? Ghost in the machine, dude. These really are the worst kinds of problems. These little intermittent issues, man, where something like this happens. If you can't find it chopsticking around, you can end up chasing your tail for days and days on end on something like this. There it goes again. Was that it? No? Something was going on right there, though. When you find something that's intermittent like that, if you can't find it chopsticking, you're at a point where you start throwing darts at a board, and that's when it can kind of get expensive for no reason, because you're starting to trade parts out, just theorizing it. Well, it might be that, or it might be this. I mean, right now I'm tapping on that V1 tube, and it just doesn't seem to be it at all. I mean, the more I'm playing with this right here, the more that does seem to be doing something. I don't know, fellas. I don't know. Okay, so I went ahead and made the executive decision to pull this board, and I'm just going over it with the microscope here, and we're going to hit anything that looks suspicious with the soldering iron. I've already come across one connection here that I can see that is definitely not very well soldered, so I'm going to go ahead and hit that one, and we'll probably hit a bunch of these. Now, this is not in the area where I would have thought that the problem was occurring. The problem seemed to be occurring in two different areas. One is over here by this connector pin assembly. Then the other area of concern was over here by the V1 tube, because when we pulled the V1, obviously, and put it back in, it sort of fixed itself. So we're going to deep clean these sockets, for one, and we're going to hit any solder joints that we can find. I'm going to look over this whole thing, and I'm hoping, you know, between these two things that we will have gotten the issue solved, but we'll just have to wait and see how it goes. Is that a crack on the board right there? Or is that just, oh no, that's just like a fluid line where somebody probably sprayed and cleaned the socket before, but it looks like it's got a lot of gunk in there. That looks really kind of, yeah, you see how it's kind of oily? I think they used the wrong type of cleaner. I wish people wouldn't do that. I think they used some kind of oily cleaner there. But let's focus in a little bit. You can see how much gunk, look how much gunk is in these sockets. Look at all that. So we've got to spray all that out. Let's go ahead and do that. I'm going to spray the socket and then we'll stick it back under there and see what kind of difference it made. We're on V3 right now. Stick the tube in there a couple times. Maybe it will push all that gunk out of the connection path. I mean, it looks like it's still got a lot of gunk in there, but can't be any worse than it was. I looked at the first socket, V1 socket, earlier, and it was pretty dirty, but it looks to me like that cleaning did a lot of good. So I'm really a lot happier with that. I'm going to go ahead and hit these socket connections to the board also. Just reflow all that solder too. Because while it looks okay, it's just, you know, I'm just uncomfortable with the fact that our problems seem to be coming from that first socket somehow. So I just want to, while I've got this board out, I don't want to have to pull it a second time. So I want to try to get as much of this reflowed and everything as possible. Yeah, that's not a crack in the board. That's just a line where somebody had used some like really oily cleaner or something at one point. So, not a problem there. All this stuff looks pretty okay. Now, when I first got in here, this connection right here was pretty close to this one, and I kind of moved it away a little bit just to get a little bit more separation, because I'm not sure what the consequences of those touching would be. Man, that iron sure got nasty fast. Yeah, I really don't see a whole lot that looks concerning in here at all. And in terms of like broken solder joints or anything. Everything really looks pretty good to me, with the exception of the stuff, you know, a couple things we've already done. I just haven't noticed anything that was real glaring, like it was obvious, except for that one, that first one that I did, that was pretty bad. That was a bad solder joint for sure. But I don't know that that would have been bad enough to cause our problem or not. This jumper wire right here. Make sure this isn't a problem underneath. In other words, the other side of that wire could be worn through somewhere and making contact. I don't see that has happened though. I think that wire's fine. I wonder what's up with that right there. Has that been drilled out? What's going on there, I wonder? Maybe that was drilled out and moved to here? Looks like that's maybe that's an original capacitor, it looks like. Or a resistor. Not sure which, but the component looks original. There was 4 capacitors that I determined could have been a possible fault. Let's see, that's one right there. That 22 nano. That one right there as well, 0.1. And then that 2.2K. Anyway, when I was flicking around on these earlier, it seemed like those were kind of not liking being messed around with. This one was one of them too that was kind of not liking things, it seemed like. I've actually got a good mind just to change that one regardless. And what is that? That's C35 on the schematic. That's the cathode bypass capacitor for V1B. That could very well have something to do with that. We got this little TR5 right here also, and I'm actually looking at the legs on that, and those look suspicious too. I'm gonna hit that one for sure. We'll hit all 3 of these legs. That's the one that had that resistor that was pretty close also. So if we look here at the schematic, let's just look at it for a second. You know, there's a lot here that is very standard, and there's some non-standard sort of stuff too. When I say non-standard, I mean in terms of what I'm used to looking at, like old school amps. The signal comes into here, jumps over to here, and goes into this first stage, right? Comes out of this stage. What do we got here too? What is this little break here? Is that a switch? The way they've got that notated looks to me like a switch, but it's really hard to tell what they're getting at here. Like I said, we do have a bypass capacitor of 22 microfarad at 50 volts in this first stage. So this is, yeah, so this isn't like 80s Marshalls or anything like that at all. Then we have what, an 820 ohm resistor. This is kind of a frequency shaping capacitor here around this tube. We've got this 22N, that's C37, that's the coupling cap. Now if that, you know, if something were to happen to that, that certainly could be part of the problem, and I think that's one of the caps we were looking at. After this 22 nanofarad capacitor, the signal could go a couple different ways. It could go straight this way, in which case it runs into C61, which is a 330 picofarad capacitor. And there's a little network here associated with it as well, including a switch when this switch is thrown to bypass this, it bypasses this little network. Is that the boost switch maybe? That's probably the boost. It must be when you throw this to this position, it's boosted because it's bypassing this little tone shaping RC network here. So apparently there's a capacitor here that they did not put in. Did they do that on purpose? I wonder what that's there for. Why did it design it with it, and maybe somebody decided to remove it last minute? I don't know. But then we have an overdrive gain into the V1B stage, which again has this C35 bypass capacitor here. This is the one I think I need to change because it was just acting suspicious whenever I would kind of touch it earlier. It stopped doing that after a while, but then it's kind of started doing it again. So I don't know. I think I might get rid of that. But this right here, this little this transistor right here is the one I'm interested in. So is this some kind of switch? This must be some kind of switch. We would have normally 100K resistor here separating from ground, but then when this switch is switched in, and it looks like maybe it is switched using a, what does that say, gain 1? Yeah, this looks to me like it's acting like a switch. That's what it looks like to me. And what it's doing probably is it's when this line is closed, it is it's connecting this point to this point, and then allowing this resistor to be in circuit in parallel with this resistor. That's what it looks like to me. But backing up a little bit, like I said, back here though, we had two different ways that we could go after this C37. We had this direction and we had this direction after this first stage. And then we run into another switch. What is this one? What does that say? 3C? There's 3A. But really, when these are switched, this whole thing is going to switch in unison. So it'll switch from here, this position, over to this position, and these will switch in unison. It looks like what's happening is this. The signal that goes this way and goes through all of this eventually hits this switch right here. So this is the switch for the channels right here. So this will be, this will add the gains, this gain stage. So you get this gain stage, and then this switch right here, if it's switched in this direction, will be pulling signal from this gain stage also, from this direction. But when it's switched this way, it'll be pulling signal from this way, in which case there's only one gain stage. See there how that's being bypassed? Yeah, sometimes you just got to stare at something for a minute. Eventually it'll become obvious, but this right here is the crux of it all on the channel switching. So we're adding that gain stage before this, which is the cathode follower stage right here. So we have a gain stage right before this cathode follower, and then that's the end of the preamp. I think I want to replace that capacitor right there, or it seemed to me earlier when I was messing around with it like it was part of the problem. So let me pull that off the board real quick. So there's what I think might be the culprit. I don't know for sure, but I actually kind of doubt it. I'm just throwing out any theory, you know, that makes sense. Unknown or damaged part. So, man, did we find it? But we'll see what this one measures at. If this measures as a good capacitor, then we know it's not the tester. This tester is usually pretty reliable. It's been pretty. This is a cool little tester. It doesn't like this one either, so maybe it's a connection problem. Okay, that's giving me a capacitor now. So let's try this other one again. Might have been an error in a bad connection on the leads. No, it's not. It's coming up as a good part, so I don't think changing it's going to fix it, but we're going to change it anyway. So. Alright, there's our new part soldered in, and like I said, who knows if that's going to fix it. I don't think it's going to hurt, put it that way. I'm going to check one more time on this side of the board over here just to make sure I didn't miss anything, and then we'll reinsert the board and see where that got us. That's about all I really know how to do. All right, guys, so I did end up going back over a lot of connections over on the other side of the board, and I found two more really questionable looking connections and soldered both of those. One of those was definitely to a point where it could have been a problem. So what we have about 3 bad connections on the whole board that we discovered, and went ahead and put this whole thing back together. Also went ahead and replaced the coupling capacitor. I wasn't comfortable with leaving it in, especially when I had to pull the whole board to do what I did. So I thought it was prudent, since I already had the thing out, I went ahead and just replaced it. It was really just a generic 400 volt capacitor to begin with, this little guy. It's been replaced with a 630 volt capacitor, so the one that I put in there is far superior. Played this thing for about another couple of hours and everything seems okay. Played it on and off and no popping whatsoever. Didn't have one single pop. So I think between soldering the board and either replacing the coupling capacitor or that bypass capacitor must have fixed it. So yeah, man, this is one of those that, you know, you never know what you're getting yourself into when you take amps like this in. You just don't until you put it on the bench or you find you start chopsticking around on it. You don't know if that's going to be an easy fix. You know, sometimes you find stuff like that in 5 minutes. Sometimes it takes several hours, which it did in this case. You know, I'm not going to bill the guy for several hours just for a couple of bad solder joints. But I mean, to be quite honest, I would be well within my rights to do it, because here's the thing that you have to understand about this line of work. The 5-minute job, you know, you're charging $80 or whatever for that because that's your bench fee, right? So 5 minutes for $80, I'm sorry, just to put it on my bench and for me to open the thing up and take the chassis out and look at it, it's going to be $80. I mean, that's that much worth my time, right? And those people kind of subsidize some of these longer ones, if that makes sense. So anyway, I mean, you can treat this however you like. If you want to bill people for the exact amount, you know, you're well within your rights to do that. It is what it is. If I wanted to bill for like all 5 hours probably that I ended up spending on this thing, because it probably was about that, you know, to pull the board and all that stuff and put it back in and do everything that I did, yeah, probably in total it took about 5 hours, plus all the testing and stuff involved. You know, because you have to go back to it every now and then and see if it's making pops and play it a little bit more and see if you can get it to fail. And, you know, all that time, it takes up from your time of your day where you could be doing something different. And if you have a repair business, you just have to decide how you want to approach these things. Usually, you know, I charge somewhere, you know, when it gets into a situation like this, what I end up usually doing is charging somewhere north of what my bench fee is going to be, like maybe for a second hour, because that's truthfully, I spent way more than that. You can't just let things like this go, because there has to be some form of punishment, if you will, for people continuing to buy stuff like this, you know, with these PCB boards that you have to pull out of the thing, you know, to even get to the other side and resolder stuff. I mean, if this was an older school Marshall, or an older school Fender or something like that, I could see everything from the top and I wouldn't have to pull a board at all. So, you know, people make buying choices, and and they're cheaper on the front end, but they're going to be more expensive usually on the back end, because a guy like me gets in there and looks at it and has to pull the board. Your price is going to go up from there. But anyway, that'll do it for this one. For now, we'll see y'all later.